We put out an email recently to our community asking them about our upcoming training sessions. So once a month, typically, we offer training sessions in the evening here in Ontario, so 7 p.m. Eastern time. And really the purpose is just to build capacity with our community to come together and do some math and really focus on content. And so I've been receiving these emails from all of our listeners and members of our academy, and we've had an overwhelming response for one
Hmm?
particular topic. That really,
Philip,
I think it
is
surprised
it
me. Maybe it won't.
surprising? Yeah, I was just going to say, is it surprising
I
this
was
topic is the.
surprised by the number of people who, it was like email after email. I kept opening them and it was like the same response, the same
Mm.
response. And then I'd get a random other topic.
You know what though? Like I've seen the emails. I know the topic, but I'm not maybe that surprised. I think it's like maybe
I am.
surprising to us or maybe surprising to you, Yvette, because we've focused on it so much over the last 5, 6 years. And I don't know, I think sometimes you feel like the quote unquote we did that happens. And
Hmm.
unfortunately, we haven't quite done that, or at least we haven't
What do you
quite
mean by that? Tell me
implemented.
more about we did that.
Every time, and we've talked about this in some of our leader episodes where, we talk about when we do professional development, we often in our minds sort of like check it off the list. Like it's like we covered that, like we did it, just like we do in class. Like when we cover a topic, we think like it's good and let's move on. But the reality is that we actually need a whole lot more time and attention in order to actually feel comfortable, confident with it. And then only then can we as educators then put it in place in our classrooms. So I think there's a lot of people that have seen some things around this topic, but may not have felt confident enough to maybe actually implement some change in the classroom.
Got it. I'm sure people are like trying to guess right now. Like, what is that topic? Yvette, hit us.
Yeah, it was overwhelmingly multiplication, but in particular, 2-digit and 3-digit multiplication.
Yes.
So I'm
Oh, how do I
thinking
make that relevant? How do I do that differently?
our
That's a
fifth and sixth
stickler in my
grade
mind.
teachers. Yes, like I know the audience. It's our fifth and sixth grade. Typically, it kind of dominates that curriculum or those standards at those grade levels, and it's a hurdle for
Mm-hmm.
a lot of students and probably a lot of teachers. I mean, I was there. Certainly, I taught sixth grade for many years, and when you just feel like they're just not getting it,
Right.
and
And
maybe
what?
the resource that you have isn't positioning them to be super successful with this particular concept.
Got it. And what do you now, Kyle? Like I know Kyle, you've had a ton of experience as well, like diving into this topic for sure. And I'm going to show my ignorance a little bit here because I primarily high school teacher. Lowest I ever taught was the 7th grade. So while I can predict where some of the hangups for kids are, where they would be in say 2-digit and 3-digit multiplication, give me what you're thinking. Like what is it like? Is it just the repetitive nature of trying to teach kids an algorithm that is like, oh, I don't remember how to put a 0 here or carry this, and it's like, or is there something else that's really like hanging people up here?
I honestly think the way we learned multiplication was very rote when it was single digits or maybe up to 12 times 12, right? And then after that, it was all algorithm and a very specific algorithm if you're here in North America. And I think it just robbed us in our own learning experience to actually understand what's going on. Like, why does this algorithm even really work? If you've never really thought about it, you probably just do it and you know it works, you trust it works, and therefore it must be the simplest way to teach other
Right.
students just like us because it worked for us. Look at us. We're teaching kids now. So it must have worked and therefore it must be the best way. But in reality, it's so critical, in my opinion, I know Yvette, you'd agree with this, that we understand not only how it works, but also developing a trajectory towards an algorithm and like allowing that algorithm to emerge so students can come at it, especially if you get hung up, because we know the students who struggle the most tend to get hung up somewhere along the lines. And if you lose your place in an algorithm without any sort of understanding or any way to sort of back map and sort of like take some steps backwards to go like, where am I, get back to that place of trust, we're in really, really big trouble. And I think our 5th and 6th grade teachers are going, I want to do something else, but like, I'm not confident. And then secondly, do I even have the time to do this? Like, how long is this going to take? So let's dig into this thing and like, let's chat a little bit about what does this look like and sound like? And, how do we help some of these educators who are listening going, I want to do more of this. I want to do well, but at the same time, I also have to be realistic about like, how long is this going to take? What does it look like? Is it all in one lesson, 1 week, 1 month, or throughout the entire school year?
I went back to Van de Waal's work because I wanted to just kind of brush up on my understanding of ways to introduce multiplication, particular multi-digit. And without oversimplifying, and I don't want to rob people of the understanding that comes from this chapter, but he essentially talked about scenarios that lend themselves to what he called invented strategies, which is what we would call like flexible strategies.
Mm-hmm.
And he basically goes to say like students need more than one method because you want them to be flexible depending on the relationship between the quantities. And so there are a lot of friendlier, let's say, 2-digit and 3-digit facts that we don't need to even touch the standard algorithm.
Right.
But then he does go on to say later in the chapter, but there are some facts, and the example he gave was, 486 multiplied by 372, where he would say, the standard algorithm is the most efficient strategy when the numbers become less
Ugly?
friendly.
Right.
So I almost wanted to like talk through both scenarios. Like what do we do or how would we support students in building understanding when they're working with facts that are maybe a little bit friendlier and lend themselves to invented or flexible strategies? And then let's talk about, when is it time to actually use the standard algorithm because it's the most efficient because the numbers are pretty ugly to work with. So I'm going to throw 27 multiplied by 40 out to the two of you.
Okay.
And I want you, and I mean, I know you're on the spot right now. I didn't prep you at all, but let's just talk through it. If we wanted to use an invented strategy or a flexible strategy to work through 27 multiplied by 40, what are you thinking?
Kyle, you want to go first?
Well,
want me to go first?
I was going to say, like, for me, the strategy that I feel most comfortable and confident with is partial products. It's like, it blew my mind when I finally was exposed to the partial product strategy, especially visually, like breaking numbers down, chunking numbers up, and then sort of essentially creating sums that we could put together. So that would be where I would resort to. But I'm like, I'm looking at this number and I'm going like, maybe there's a better way. Like I like trying to think outside the box a little bit. And I go, like 27 times 40, when I look at that number, 27 times 40, like 27's close to 30. And
you stole my strategy.
Okay. Sorry. I thought maybe you were going to
keep going.
Partial
Keep going.
Products.
No, I did.
Like I look and I go, well, like 30 times 40 is like really close. But then right away, I definitely know that students and myself included would go, am I flexible enough to go like backwards and
right.
And move down? Because
how often do you see kids do that, right?
100%. Like that's where I would want to definitely draw this out and sort of make the 30 by 40 and then like try to figure out where am I going to have to take away? Because I think sometimes they go like, do I have to take away like 3 27s? Do I have to take away 3 fees? Do I have to take 3 of some other number? Like that's where things get a little tricky with that type of strategy. But I think the more we can expose students to these types of strategies, and doing this in like number talks and such at the beginning of a lesson can be really helpful to almost, create the opportunity for them to apply it. But then also I like to say sometimes force them, because I think until we actually have them try some of these strategies, like it's just going to be an idea that they're not feeling confident to actually put into place.
Yeah, so you described basically, a partial products over subtraction scenario, which I agree. Like maybe if this was 29, that would be super obvious. Like typically when the number is close to a 10, we want to, like overestimate and then compensate. What I did with this one is I really like 25 times 4. So I decomposed 27 into 25 and 2. And then I did like 4 times 25 is 100. 2 times 4 is 8. That's 108. And I just need it to be 10 times greater. So it's 1080 because 40 is 10 times greater than 4. So what I actually did is on the left, I decomposed in an additive way. I was like 25 plus 2.
Yep.
But then with the second factor, I factored it, and I was like 4 times 10, so that I could then just multiply by 10. It doesn't really matter. What matters is if it's efficient for you.
Right.
Yeah.
Right? Like, we're talking about flexibility and efficiency. And I think that what Van de Waal describes is like, we want students to have these different strategies in their pocket. And a lot of them rely on decomposing and composing number, but we need a lot of opportunity to live in these strategies.
Well, and one thing I want to make sure we don't like gloss over here, I did not hear you say like take the 0 and place it over here for a bit or anything like that. Like, you were very clear that you actually factored the 40. And I think for us, trying to get clear in our own minds as to what I'm actually doing when I decompose numbers, when I factor numbers, like, these are very important for us to understand, maybe not for the student yet, but why it needs to be clear for us is so that we can model that and we can help them better understand what's going on. Because if we start using tricks or like what appears to be magic for a lot of students, where like we take a 0 and put it over here and then we'll bring it back in later, like if there is not a clear understanding for them, they will start taking digits and doing random things with them at certain times because they think, the magic will sort of, take over. So I really think it's critical that when we're using some of these strategies that we do it, we do the work ourselves, but then we also try to think of like, how are we going to articulate to students what happened here? And then also, how do I articulate to a student what they did? Because sometimes they'll be flexible with the numbers, but they can't describe it themselves. That communication takes time. And I think that's a really important piece here, because if we start getting flexible, but we're not clear on why or how, and a student asks a question, that's where things get a little bit muddy really fast. And I think that's where sometimes we might shut down and go like, I don't know if this is the right move for me. And we just have to be comfortable that that's going to happen sometimes, but let's make it a goal of ours to try to be very clear as to why what we're doing makes sense so that our students can understand and apply those things as well.
Right. Like, I think what you're describing here, and I what Ed was alluding to, is that we need to create opportunities where students use their flexible strategies, use their own thinking to try to solve this problem. But then also, like, I think what we need as teachers is, what does that look like? Like, does that look like as a free-for-all in the classroom? How does the consolidation look? Like, what is everyone trying something different in groups? Like, Yvette, maybe share some of the insight here. If a teacher was like, okay, it sounds like what you're saying is I need to give kids more upfront, maybe friendly numbers to experiment and work with these types of flexible strategies on their own. But then it's like, do I lead them to this algorithm anyway? Like, how does the lesson end? Like, what am I really trying to do here from a perspective of like where we're trying to go in terms of the learning goal with students?
So I think that I will be clear that with 27 multiplied by 40, I probably wouldn't lead them to the algorithm. I don't think the algorithm is the most efficient strategy when you're working with numbers that are friendly. I think that what you're saying, though, is like, we're not just going to, throw 27 multiplied by 40 out and allow any type of strategy, efficient or inefficient, and not create some scaffolding so that students are starting to own new, more efficient strategies. And that's where I think, and we've talked about this all the time, like carefully crafted problem strings are a really great way to do this work, because you are facilitating the conversation, you're listening for particular strategies to emerge, then you're modeling them on the board, you're being explicit, you might be okay, this student just shared this strategy where they factored, let's look at another one. This is another one where, you have a multiple of 10. Can we use that same factoring strategy with this next problem? Now you go and practice it and try it on your own. So you're definitely, creating this scaffolded opportunity where you, as the facilitator, have the learning objective in mind. So like, if I want students to see that they can factor 40 into 4 times 10, or, any multiple of 10 or 100 can be factored, and then we can multiply it by 10 at the end, I'm going to select particular problems in the string where that strategy makes sense.
Yeah.
And I'm going to facilitate learning to get us there by the end of the lesson.
Yeah.
By the end of the math talk.
Yeah. And we said like that the thinking that you just described there is like, you think about it in terms of like when you flip the page to say like tomorrow I'm going to do two-digit by two-digit multiplication. That's nowhere to be found. Like that's not in the book that says like structure it this way. You make sure that you scaffold it this way. And the learning goal actually isn't to just multiply any two-digit by two-digit numbers. Actually, the learning goal here today was for us to decompose this numbers this way, or to think about factoring this number this way. And that's the kind of pathway I want you to go down, because our goal spread across a number of lessons likely is that we're trying to build flexibility in terms of strategies that says, almost like give kids permission. It's okay to solve problems in or different ways, and that's the goal. Is actually to understand and unpack how can we multiply in different ways so that you feel comfortable with that strategy or this model or say this algorithm when we say unpack the algorithm itself. Like I think there's a lot there in that statement that you kind of said.
Well, then you did. Sorry, go ahead, Kyle.
Oh, no, that's okay. I was going to just hop in and say, like the one thing I love so much about different number strings and such. So, for example, Kathy Fosno's work, a lot of the work that we've done at Math Moments have taken similar paths to get there, is like that 27 times 40. Instead of just randomly starting there, the string might be like, it might actually be 25 times 4 to start. And then it might be 25 times 40. And then it might be 26 times 40. Then it might be 27 times 40. And then there might just be a random one that's a couple moves away, but follows the same pattern, so that we can really be explicit for students. Almost like it back maps what you're doing, but right from the start, from the thing we knew, the thing that felt obvious, and then making small adjustments to kind of increase that flexibility. And I think that is so critical for us, that, when we give 27 times 40, you did it to us, but I think you knew we had a little bit of background here where we could play with some of these, and you can do that with your students at some point. But when we're trying to introduce some of these moves, we want to make sure that we give them low hanging fruit at the beginning, and we inch our way or inch further from that low hanging fruit, so that they can then go, oh, you know what? When I do see something that isn't as familiar, I can kind of work my way backwards and get there.
So you mentioned the standard algorithm, and there's such a debate right now. Like I see it all the time in social media about like whether we need the algorithm or not. I always like to say I think we live somewhere in the middle of that debate. And so Van de Waal did also explicitly state in the chapter, there are situations where that is the most efficient, because decomposing it is going to become so complex that, it's going to be hard to hang on to and all these things. So the example he gave was 486 multiplied by 372. And I think the problem that a lot of our grade 5 and 6 teachers face is that's the problem that will be in the book on day one.
Right. The first example.
The first, like, it's like in these textbooks or resources that I've used at this grade level in the past, it's like they interpret the grade level expectation
as the
at grade level without any scaffolding leading up to it, and with very unfriendly numbers. And so teachers are almost, they feel like I have to just jump to the algorithm. So what we would argue is, go back, work with 1 digit by 2 digit, 2 digit by 2 digit, 1 digit by 3 digit, take the time, work with friendly numbers, build up students' flexibility and understanding, because the reality is they're not going to encounter these really unfriendly 3 digit by 3 digit often in the real world where they can't use a calculator. Mm-hmm. So like to spend time, banging your head against the wall with these facts and these facts only that are super unfriendly, I don't know is the best use of time. But does that mean that we never teach it? I don't think that's true either. Like, I do think that there is an opportunity for us to build understanding of the standard algorithm as another tool for their toolkit when the numbers are unfriendly and reasoning through it is going to be too laborsome. But what we often see in textbooks is they jump right to the steps and they jump right to memorizing the steps without the conceptual understanding. And Kyle, that's where I did a ton of learning with you and from you around the use of the array model and how powerful that tool is as a starting point for the standard algorithm, even a concrete array. And the example that Van de Waal gives actually is like starting with the concept of area. So like use area of a rectangle, create
it makes
a context.
sense.
It's like a garden, and the garden is 46 meters by 12 meters. and we're trying to figure out the square meters of that garden. So it's very concrete. And then basically it's like we are going to learn the steps, but the steps built on the visual and built on the conceptual understanding versus just expecting that they're going to memorize and be able to put the zero in the right place or shift the digits without any understanding of why they're doing it.
There's a huge bonus too with like really giving you an opportunity to talk about units of measure, which we did a lot of work together on as well, Yvette, in terms of, how often are there scenarios where kids come up with a number, but then there's no units or they don't know what the units are. Is it centimeters? Is it centimeters squared? Is it centimeters cubed? Like instead of just having these rules that like area is always squared and volume is always cubed and, all of these things, you can actually make sense of it and it makes it obvious to students. So when we do play in that area model, you literally can count these like squares, and like students can really get familiar with like, oh, there's a reason why we're doing this. And it's not just some random rule. And you start to see students making more and more sense, not just around multiplication, but around measurement. And they start to understand other parts and they start to see math as that connected subject that we say it is, but that a lot of students never actually experience themselves. So for me with the standard algorithm, like if someone said you could only teach one strategy for students to be flexible with, it would be partial products because it does connect so nicely to the standard algorithm. Now, that is not me suggesting you should only focus on one, but I'm saying if there was only one, like that one is going to have a huge amount of value, especially since whether we agree or not that the standard algorithm should be taught or shouldn't be taught, the reality is many curriculum, it is there. And therefore, if you are going to be doing the things that you're supposed to be doing as a math educator, like that's going to be a huge, huge model. So it's a great place to start. If let's say you're going like, listen, I've always just taught the algorithm. I know that it's not helping all students. Where do I begin? Like that, I would say is a great place to start. It's not the only place. It's not the place to end, but you're going to see some quick wins, in my opinion, when you get more flexible with it and you help your students to become more flexible with it, because they're going to start to go, oh my gosh, this is the exact same thing, which it really is, just following a very specific way to partition or to decompose the digits.
Okay, I'm going to unpack the elephant in the room here just for a sec, because everyone who's listening, who either they're supporting teachers or they are, you are a teacher and you're thinking about this and you're thinking, okay, like I've typically been jumping in this way where I'm supporting a teacher who's always just kind of gone by the book or gone by the resource that they have. And it does start with 486 by 372. So I have no choice but to teach the algorithm. The timing, talk to me about the timing. Talk to me about time itself, because I think the elephant is like, well, how do I stretch this across is it all typical time? How do I make this work if I'm dedicated to helping kids develop flexible strategies, starting with easy numbers, flexible numbers, working on those strategies, giving them practice time on those strategies, introducing the model that actually like makes sense if it is the area model, and then using that area model with those strategies, and then all of a sudden ending with the algorithm eventually, because it is, like you said, you're not going to not teach it. So because everyone's like, that's a lot of time. Like, is that a year's worth of time? Like, where does this fit in? Like, help address. Like, what are some of the creative approaches you guys have taken?
Did you see me set up for this? It's really
I saw you.
I was actually reviewing a curriculum that a district was looking to adopt recently. And right away, I was really scared because I noticed that the unit on multiplication and division was in May in the pacing guide for 5th grade. And like I even just
only be adding and subtracting from now until
then. And it's like, of course they're doing other strands, and those strands
sure.
are going to integrate multiplication division, but the actual explicit instruction on multiplication and division, where they're likely tackling 3-digit by 3-digit, was 3 weeks in May.
Oh my God.
And I was really scared, even if a teacher just looked at the pacing guide at a high level view, that the story that would tell is that we're not multiplying and dividing until May.
Right.
And I truly believe that multiplication and division are a year-long concept.
Yes.
And it cannot be limited to a 3-week cycle or a 4-week cycle. It's like this has to live and breathe within your... And I think that's maybe why we struggled with it, to be honest. It's like we treat it as a unit.
Yeah.
But that's never going to be enough time.
I love it.
Unless we're really explicit, right? Like we're really looking at the multiplication and division.
So you're fitting it in, right? Like you're fitting it in here. You're fitting it in here. It might be the beginning of this warm up or this warm up. Maybe you have a small group over here. You have this activity that's running. It's an all year thing. And by the end of the year, you've covered all of these pieces and you've broken it up. So you're talking about space practice. You're talking about space learning versus mass practice, mass learning. And I think I'm so glad you said it, because in a way, as a high school teacher, that's exactly how I treated algebra at, say, the 9th grade, the 10th grade, when we introduced, say, expanding, factoring, all of that. It was a semester long tackle. So we weren't waiting till the quadratics unit before we got into that. We were multiplying strategically with different ways all the way through, just like you're suggesting. You're going to approach 2-digit and 3-digit multiplication.
If anybody wants to join us when we tackle multiplication, that's going to be our topic for October. So Typically it's on a Tuesday, Wednesday in October. If you aren't receiving that communication, reach out to us and we'll share the link with you. And this month is going to be addition and subtraction. That was the second most popular topic that came in from the request from the community. So we're going to start with addition and subtraction in September, and then October, we're going to focus on multiplication. We're going to model some of the strategies that we described here today.
You can find all of these events, all these trainings over at makemathmoments.com/training. If that's where you're going to find, say, the subtraction webinar, you can register right now for that. If you're listening to this in live time, like when it airs, every month we're going to put a new one up. So you can always go back there to that link and see what's coming up or see what's available for you to register to. Also, we're also going to put the replays up there too. So if you miss it, and you can always see also what we did last year. We had a year's worth of trainings up there now to go back and have a peek in. Like last year, September, I think, what did we do? We did division.
That's right.
Yeah.
My friends, hopefully this has been helpful for you. Head on over to makemathmoments.com/trainings if you'd like to check those out. And we're looking forward to digging into some more of these popular topics here as the new school year emerges.